Hello friends, today let us learn about what are angles in the alternate segments and what is the relation between the angles in the alternate segments. The theorem is, if a line touches a circle and if a line touches a circle, let me take this point. If a line touches a circle, let me name it as P, and from the point of contact, a chord is drawn, let me name it as Q, PQ is the chord. The angles between the tangent and the chord, see, if this is the tangent, and let me name the tangent as RS. So the angles between the tangent and the chord means one is angle QPS, other angle is angle QPR. Equal to the angles in the corresponding alternate segments. Let me explain you here what are the angles in the alternate segments. If PQ is the chord, we know that the chord divides the circle into two segments. This side one segment, this is another segment. Let me name it as A. PAQ is one segment. PBQ is the other segment made by the chord PQ. So let us join AQ, AP. So the theorem is, the angles between the chord and the tangent, means one is this, is equal to the angle in the alternate segment. That means we have to prove that, or it is already proved that angle QPS, that is this angle, is equal to angle PAQ. That is first one. And one more angle formed by the chord and the tangent is angle RPQ. This angle also equal to its alternate segment, angle in the alternate segment. So let us join BQ and also PB. Angle PBQ is the angle in the other segment. So angle RPQ is also equal to angle PBQ. That is the theorem given. Let us see how they can be proved. Let O is the center of the circle. Join PO and produce up to D. Okay? And also join DQ. Also join DQ. Let us see why and how they are equal. Now you see children, angle QPS, this angle DPQ, this angle, the sum of these two is 90 degree. Because OP is the radius, RS is the tangent, radius is at the point of contact. So the angle between the radius and the tangent is 90 degree. So angle OPS is 90 degree. Let us, for our easy understanding, let us take angle QPS as X. This one will take as X. If this is X, this is 90 minus X, because complete angle is 90 degree. Okay. Now, this line PD is passing through the center. So PD is the diameter of the circle. So angle PQD is 90 degree. Now in this triangle PQD, this is 90 degree, this is 90 minus X. So this angle will be 180 degree minus 90 plus 90 of minus X is, you will get X degree. 180 minus this and this gives you X. Now you see angle PDQ and angle PAQ are the angles in the same segment. So if this is X, this one also X. Now you see we got it. Angle QPS is x degree. Angle PAQ is also x degree. That is what is our first one. The angle between the chord and the tangent is x here. The angle in the alternate segment is angle PAQX. Okay. Now let us see how second one can be proved. Now you see children, what about angle RPQ? Angle RPQ is equal to, same way this is 90 degree. Otherwise complete angle is 180 degree. So angle RPQ will be 180 minus x. Angle RPQ will be 180 minus x. Now what kind of quadrilateral is APBQ? APBQ is a cyclic quadrilateral. We have already learned that in a cyclic quadrilateral, opposite angles are supplementary. So, if this angle A is x, angle B opposite to this is 180 degree minus x. So, we got angle PBQ also 180 degree minus x. So, you see, this is also the angle between the chord and the tangent. Angle RPQ is 180 minus x. Angle PBQ also 180 minus x. So the theorem is proved. The theorem, if a line touches a circle and a chord is drawn from the point of contact, then the angles between the tangent and the chord are equal to the angles in the corresponding alternate segments. Okay. One more theorem let us have now. When a chord and a tangent intersect each other externally, then the product of the segments of the chord is equal to the square of the length of the tangent. If a chord and a tangent intersect externally, then the product of the segments of the chord is equal to the square of the length of the tangent from the point of contact to the point of intersection. To the point of intersection. Now let me draw the figure and explain you. This is the circle. If a chord and a tangent, let me draw a chord AB. Like this is a tangent. The tangent is touching the circle at P. If this chord and the tangent intersect externally, let me produce AB up to T. So this is external intersection because AB is produced. If a chord and a tangent intersect externally, the product of the segments of the chord, this too you have already learned that the segments of the chord AB are TA and TB. That means TA into TB, that is the product of the segments of the chord, is equal to the square of the length of the tangent from the point of contact to the point of intersection, PT square. In order to prove this, let us join AP and also BP. Now we got two triangles, triangle ABP and the triangle ABP and triangle PBT. Just now you have learned in the theorem that the angle between the chord and the tangent is equal to the angle in the alternate segment. So this angle is equal to this angle. In triangle ABP, in triangle APT, let us ATP. Sorry children, this is in triangle ATP, the larger triangle ATP in triangle PBT. This angle is equal to this angle. Okay? In the bigger triangle APT, this triangle, this angle, in this angle are equal. And in triangle APT, this angle T is there. In triangle BPT also, this angle is there. This is the common angle. So these two triangles are similar. If two triangles are similar, their corresponding sides are proportional to each other. For your better understanding, let me explain you. In triangle APT, this complete angle is equal to this angle. Okay, let me do like this clearly. Okay. Now you see, this is common angle. Let me write this one. So when these two triangles APT and BPT are similar, their corresponding sides are proportional to each other. So in the bigger triangle opposite to this angle is, what is this? TA. When these two triangles are similar, corresponding sides are proportional. And in the smaller triangle, this equal to this, opposite to this is PT. TA by PT is equal to, now in the bigger triangle, opposite to this is PT. And this angle is equal to this. In this triangle BPT, opposite to this is TB. So when you cross multiply, you will get TA into TB is equal to PT into PT is PT square. So what did we learn? What do you learn? What did you learn? If a chord and a tangent intersect externally, the product of the segments of the chord is equal to the length of the tangent from the point of contact to the point of intersection. With this, I have come to the end of chapter circles. Clear? Did you understand? If you like my channel, please like and also subscribe. Thank you so much.